origin story of Emergent 3D?
So I had been watching this technology for a while. And I grew up in a family of builders. My dad and my uncle were custom home builders. I had stumbled upon 3D printing, just doing as you do, going on YouTube and seeing, and I have 4 boys that are 12 and under, and I wanted to know what the job market was going to be like when they graduate. And I stumbled into 3D printing, and then construction grade 3D printing of homes and structures, and my mind got blown. And so our family, my wife and I and our kids, we moved here to Reading with the desire to start what I didn't know was at that time Emergent 3D, but to help address the housing challenges. We moved here 2 weeks before the Carr Fire, our national disaster. And then I got hired. This economy went upside down, and as a disaster recovery zone. And I got hired on for the FEMA-funded contract for the disaster case management program. And that's how Don and I met, in being in the middle of our community who was grappling with how are we going to get recovered. We already had low, tradesmen and women, just not enough of the work, just in all that goes into it. And I realized, oh, this is going to be a solution, not the solution, but to help, address our recovery effort. And that was kind of the genesis of Emergent 3D, and the impetus is to try to get our disaster recovery families rebuilt quickly and in more fire resilient homes, and 3D concrete printing that technology was coming to the point where it could actually deliver on what it was promising. And so I founded Emergent 3D back in 2019.
And Don, from your perspective, you meet Matthew through the FEMA program, and tell me a little bit about your background and what you bring to this, and kind of what excited you about this and excites you about this.
I've been a Shasta County resident for 32 years and have been a general contractor, a licensed California contractor for actually about 37 years. So when we had our Carr Fire, FEMA came in and gave us the notebook that was about this thick that says, this is how communities like yours recover. And I was asked if I would join the long-term recovery committee that FEMA had established, and asked if I would run the construction subcommittee. FEMA had identified some 300 homes that were lost by people who were either completely uninsured or severely underinsured. We needed to find a way to get them back into housing. So it was during those meetings, we were meeting sometimes twice a week for a couple of years. It was during those meetings that I met Matt, and he told me this story about 3D construction printing using concrete. And if I'm being honest, I was quite skeptical. Kind of the old builder in me is, I'm old enough to know the history that California has had with unreinforced concrete buildings and seismic issues. And so I thought, maybe in a third world country and maybe other places I could see that, but I'm not so sure that's going to work here in California. But Matt had persisted. He got an architect going, he got a licensed California structural engineer going, and they came up with a system that when he presented that to me, I thought, oh my gosh, there may be something here. And I was fully intrigued, because now not only do I see that maybe there's a way to actually do this here in California, but it really addressed all of my pain points, which are labor force. Most people in construction, my age, when you're at my age in construction, you're starting to age out of the industry, and the numbers reflect that for every 5 of me, there's only 1 coming in. And so in my mind, that means we need to automate the industry by 80% just to keep up. And the fact is, we're not keeping up. California has a huge housing crisis. So this squarely addresses that. To be able to automate part of the construction process squarely addresses that. So another one of the big pain points is the material cost. And the beauty of 3D construction printing is that when we print those walls, we're not only creating the structure, but that is also the exterior finish and the interior finish. And so we have just saved all that material as well, on top of the labor that represents. And then there is the unique designs we can create. We can do curves and angles and bevels. My entire career has been straight, square, and plumb. And now we get to do these curved, beautiful, organic structures that actually are quite affordable with 3D printing. They would be extremely cost prohibitive in traditional construction, but now we could actually execute those with a printing robot. So it really, it addressed everything I had concerns and dreams over. It squarely addressed it, and now we actually had a structural and an energy path towards getting it approved in California, and sure enough, we did get it approved here in California as what we believe is the first on-site 3D printed house that is approved per the California Building Code. So we are primed and ready to start building.
And the goal is next month, sometime in September, right?
That's correct. So the last of our equipment shows up actually on the shores of California, perhaps tomorrow, August 4th. And then we expect it to show up via truck up here in Redding by about the middle or end of August, by the time it clears customs and gets up here. So we could start printing by the end of August, we're hoping.
So once you're able to start printing, tell me what your plans are. Who are the communities, the clients that you are hoping to serve? Because there are a lot of, like we talked about, there are a lot of needs with this affordable housing, or this, not just affordable housing, just a housing availability crisis in California. So who are you building for?
Because our company rose out of the ashes of the Carr Fire, originally it was kind of narrow where we wanted to focus on the disaster recovery folks. But as we have moved forward and progressed, and the Camp Fire happened, and then over the last several years, I think the numbers are in the last 4 or 5 years, 50,000 homes and structures have been burned down in our wildfires. It's not only that, but we have a huge shortfall of total number of living units, here in California. And so we really want to help address workforce housing, affordable housing, disaster recovery, and homelessness recovery housing. Now, as we've moved forward with that, we are having other clients that are coming to us and are pushing us forward. So we're working on the first 3D printed church in the world right now. So commercial buildings and on it goes. The 3D printing really opens up a full spectrum of things. And so, but at the end of the day, we want to help address the California housing crisis. And so the whole spectrum, from homelessness recovery to custom built homes to workforce housing, everywhere in between, because one more unit built is one more family in a house.
Yeah.
So.
And it's really our hearts, it's in our DNA to do exactly that. My time with the long-term recovery was fully voluntary. This is my community and I wanted to help. But I would be less than truthful if I didn't say that we have some amazing designs for some custom homes that I am so looking forward to someday being able to build, because these are styles and designs and shapes that I could have never executed in conventional construction. So that is a huge part of it for me as well.
Are there any barriers that you have found that maybe spill over from traditional home building, whether that's permitting, zoning, fees, that you say maybe this needs to change on a higher level, that no matter the equipment, it's something that needs to change by our elected officials?
We did a presentation to the city of Redding, to some of the leadership of the city of Redding, the city manager, the head building official, the fire marshal, and we were presenting to them, telling them about all these benefits, like the cost savings and the design palette, and perhaps the first in California to 3D print. And we're saying all we need is an approved set of plans. And the city manager of the city of Redding stood up with his hands in the air and said, "Yes, I want Redding to be the first in the state to 3D print a house." And the head building official at the time, as he was saying that, the head building official put his head in his hands and said, "Oh my gosh, I have to approve the first 3D printed house in the state of California."
No pressure.
Nope. Yeah. Because generally speaking, building officials by nature, and I'm thankful for it, they are very, very conservative. Anytime I have ever presented them with anything that's slightly outside of the box, they ask me, "Well, where has it been done before? Let's see what they did." And this time, I didn't have to do that because the king spoke, and so we submitted these plans. And when you ask about plan check, it went through 4 rounds of plan check. The city of Redding actually pulled one of their structural plan check engineers out of retirement to assist in scrutinizing this system. So the city of Reading actually had a total of 3 structural engineers, and we had 2 of ours, and they went back and forth 4 times inventing an industry. That's the best way I could put it, like creating an industry and creating code applications that exist today but that apply to this new method of construction. And so it was a lot of work, it was a lot of focus, but we had the directive of the city manager, so it happened. What I can say beyond that then is once we had that approved, now the milestone of where has it been done before had been reached. So we had 3 other jurisdictions that once we submitted that to them, they said, oh, okay, I see what you're doing here. And they had a couple of questions here and there, but we ultimately got it approved after the city of Reading. We got it approved in Shasta County, in Butte County, and in the town of Paradise as well. And those are all high focus areas for us.
Proprietary elements aside, is this something that you would share with other municipalities? This is how you do it. Here's the path forward in terms of permitting, in terms of, so they don't have to invent the wheel when you already have a prototype.
100%.
Yeah, absolutely. And we got the opportunity to present at RCRC, so Rural County Representatives of California, their annual conference last year. 37 counties, their leadership teams represented there. And we just came and wanted to present the good news because every single one of, across California, everybody has a housing challenge. And it's acute in the rural counties, and so absolutely, and we actually started getting those plans approved in advance just to get them familiar with it, so that the more jurisdictions that are looking at this, getting comfortable with it, getting it approved, and we're really excited about just in the last couple of months in the town of Paradise, because that's a part, again, our heartbeat. We want to, and will be proactively trying to bring housing back to Paradise, in addition to all the other areas, but because of the mass devastation that happened there, now we can. Now we got a master plan approved there in Paradise, and we're looking to do our first one there this fall.
Emergent 3D can't solve the problem alone. So as we gain knowledge, we want to share the knowledge. There's a massive problem in California with housing, and so the more help we can get, the better. So we're willing to share, absolutely.
Great. And I imagine once your equipment is in Paradise building one home, you can just move it to the next site. You don't have to bring it back here. So you can kind of just hopefully go from site to site, however many homes are being built.
That's correct. It's actually part of our plan that when we land in a community, we stay in the community. We want to hire locally and keep them there. For years, my construction company would send employees out of town to work Monday through Friday and then come home, and that can get taxing on a family, and so we don't want to do that. It's our belief that once we start in a community, they're going to love it. They'll love the product, and it is our intention to actually land there. And so part of that plan, of executing that plan, is that we've partnered with LIUNA. We are a signatory company. We use union workers to do this, and so as we go into a new community, they help us identify a great team, and we will get them specially trained for our equipment, and then put them to work. These will be, we not only want to benefit the community by creating this housing, but we can help them create jobs. And the beauty of it is that these are tech construction jobs, whereas before I gave you the 1 in 5 ratio. Well, now I'm not trying to recruit somebody to dig ditches or swing a hammer. They can actually control a computer robot with their thumbs, and I'm aging myself, but the younger generation's very good at that. And they are very interested, and as we have presented to groups of younger generation folks, this is something they are highly interested in because it's a tech construction job, and that really speaks to their hearts. And not to mention that we're wanting to do good for people. It speaks to a younger generation, certainly.
Well, is this taking away jobs? Is it, that's one of the big questions in our society about, bringing in robots. Are those replacing, human jobs? But there's a labor shortage. So this is supplementing an already short industry and creating this great product. One thing that you brought up that I just want to make sure that I don't forget to ask about is earthquakes. How are these homes earthquake resistant?
They have clearly been designed with California in mind. That said, California has different seismic zones, and we have not had this scrutinized and approved all over the state. in our very specific jurisdictions where it's been approved, it has been approved for the seismic loads in those areas accordingly. Having said that, our construction style, if you can imagine the system, it's similar to a parking garage, a concrete parking garage with posts and decks and beams and so on. And certainly parking garages exist in the highest of seismic zones. It just might require bigger rebar and more concrete, that's all. So it can be done. We haven't done it everywhere, but we haven't had the need to do it everywhere.
The industry can cross that bridge when it gets there, and hopefully it does, because that means it's growing. But for what you're starting here, it's all good in the seismic zone, yeah.
And then regarding your comment about taking jobs, there's actually, the way I frame that, because I've heard that many times. And when I first approached LiUNA to partner with us, they brought up the same thing. Well, you know, Don, I'm not sure that we want to support something that might be viewed as taking jobs. And I said, you know, let's think of it this way. There's a limited number, like we have some limited resources. There's a limited number of construction workers out there, and there's a limited amount of money, like to rebuild homes and to, you know, to solve our housing crisis. If we can reduce the cost of building a home and reduce the number of man hours, we can simply leverage those resources to produce more homes. We are creating jobs of the future. These are tech construction jobs that don't exist otherwise, and now we can leverage those limited resources to actually build more homes, and that's the ultimate goal.
It's just a force multiplier is what it is. And so for those that, oh no, the robots are coming, we need the robots to come. Because again, going back to that stat that Don shared, for every 5 that retire, only 1 is coming in. And so we need something to plug that gap. And then also, not to mention safety, that is safer, you know, and so there's a lot of benefits, you know, to it, and we need to go in this direction. Otherwise, costs will continue to go up because of the limited amount of labor.
How much is one of these homes, you know, and how big are they, and what, you know, does it look like some cave on the inside built out of cement? You know, I know you can share some of the designs, but for all of those, you know, who, what, when, where, why type questions people have.
There's a big misconception all over social media that, you know, you can build a 3D printed house for $25,000 or some ridiculous amount. It's still construction, and there is perhaps 75% of the home is still the same as conventional construction. We're still putting conventional wood trusses on top. We're still putting roofing on there. There's still electrical and plumbing and cabinets and floor covering and doors and windows. There is still all of that stuff. And all those costs have even gone up over the last couple of years. And those still exist even in 3D printing. We are simply printing the walls for now. Interior walls and exterior walls, but we're printing only the walls. Having said that, we have a current design. The one home that we have designed right now that is 1,200 square foot, 3-bedroom, 2-bath. We are estimating that by 3D printing it, we're saving about 11%. Now, you can apply that 11% all over the state. Here in Redding, California, the average price to build a home may be $300 a square foot, where somewhere else in the state it's $500 a square foot. I think the 11% will apply anywhere, you know, that savings. Now, a big part of that savings comes from the fact that when we actually print our walls, we're not only printing the structure, but we're printing the exterior finish and the interior finish. All it needs is paint. Now, if somebody wants something different, if they want some stone on the exterior or some siding or other things, certainly any of that can be done, but it will add to the cost naturally. If they want some different looks on the inside, absolutely we can do it, and it will cost. There will be opportunity to save more money as we go. Our very next version of 3D printed design will include actually 3D printing the foundation as well, so that we don't have to spend all the time in setting up form boards and then taking them down afterwards and making sure they're perfect. We can have the computer perfectly lay out that foundation exactly where it needs to be, and we don't have the mistakes and we don't have all the labor required in doing that. So I see a day in the very near future where maybe that 11% can bump up to maybe 20%, which is significant if you think of the overall cost of a home, correct?
And to your question about the size, as we were talking about before, there's lots of companies that are doing great things out there, and it sounds a little bit like splitting hairs within our industry, but we are a site-built, 3D printed company. And so why is that important? The reason that's important is we just recently got word that Fannie Mae and Freddie Mac has approved our homes for conventional mortgages and lending. So rather than being in a factory-built or modular home, lending. So that's very important. And then also for the insurance, that's a critical component that they look at. Our printer that we will be taking delivery of in the next couple of weeks, the print area, it can do a 3,000 square foot single story or 6,000 square foot two-story. We can add onto it the printer and go larger, and we intend to, we're already in the process of designing for multifamily, so we want to address that market as well. But the one that we have right now, that's about the scope and size. But as the projects come in, we'll get more printers and we'll do the bigger projects.
And the beauty of the equipment that we have is that it is modular. So that 3,000 square foot print area, it could perhaps print 3 600 square foot cottages if if it's all within the print area. Or if you have a 6,000 square foot multifamily, you just set it up again. Like you set it up and then you spend a day or two, take it down and you set it up over there and you print the other half. So it is fully modular. We can set up smaller. We can actually go longer, almost infinity, if you want, So it is certainly scalable. Before COVID, before we had the global supply chain issues, a typical 3-bedroom, 2-bath house could be delivered in 4 to 5 months, start of construction to finish. Today, that same home will take close to a year, just because windows take forever to get, cabinets take forever. Everything is much slower. So I guess I'm going to speak in relative terms. On the time frame, there is so much less labor that we can deliver it in less time. Cost savings is about 11%. I'd say time savings is probably closer to about 20 or 25%. Because there is just so much less labor involved.
The printing of the walls, that could take less than a week, you're anticipating, but it's all the other stuff that goes into it.
It's all the other stuff, yeah. So if the average home is taking 8 months to build, just because of supply chain issues, perhaps we can get this 3D printed one done in about 6 months or so, but it's not because of the 3D printing part, because our 1,200 square foot home, it actually calculates at 31 and a half hours of print time to print the home. And so we have a day or two of setup, 31 and a half hours of print time, and then a day or two of teardown. But we still have a global, supply chain issue, and that's what's going to hold us up still. From our perspective, any savings that we can realize because of the build process will absolutely get passed on to the end user of the product. Whether that's everybody's business strategy, we don't know, but that's certainly ours. So we haven't even printed one yet to really get real numbers to the amount of labor savings. I can just tell you anecdotally, from what I've seen other companies doing in other parts of the country, and from what I anticipate for us, so I can give you an example. When we 3D print our home, I don't need a stucco crew to come in because our walls simply only have to be painted. However, I've got a couple of gable ends that need stucco on them. So I will need some stucco work to be done. It's just instead of a crew of 4 guys for 2 weeks, it might be a crew of 2 guys for a week. Drywall, for example. I don't have to put drywall on any of the inside walls, but I still need it on the ceiling, right? On the bottom of the trusses. So instead of a crew of 4 guys for a week or 2, it's a couple of guys for a day or 2, perhaps. So I don't have the hard numbers to answer the labor savings question, but to me it goes back to the leveraging of that labor. Now I could take the 4 people that were going to be on that house and actually put 2 here and put 2 on another house, so maybe we can do twice as many homes with the same amount of labor.
And some other areas where there could be cost savings, not necessarily within the construction, but within our energy calc for the performance of the home. In our worst orientation, north, south, east, and west, it calced out about 29% more efficient than the 2020 code, California Building Code requires. So just anecdotally, obviously once our customers can get in, but there's a print that was, a house that was printed by Habitat for Humanity down in Tempe. The last article that I saw, or a story that I saw, the family hadn't had to turn on the heater or the air conditioner yet. So now we're in the middle of summer, maybe that is the case, but that's going to be an overall reduction of the energy bill. And so there's savings there that is really important, for a lot of especially within our families that, lost their homes and are trying to get recovered, and their, insurance money isn't going as far as they had hoped. And, so that's once they get into the home, will be savings there.
And I'll tell you, one of the coolest parts in my mind is, we talk about the cost savings and we talk about the energy efficiency and the labor savings and all, but the 3D printer can actually do a radius corner more easily and cleanly than a 90-degree corner. To do a 90-degree corner, it has to stop, reposition, and start again, as opposed to flowing straight through. So we can do these beautiful designs that previously were not available to us and still call it workforce housing, still call it affordable housing. And on top of that, in my career, I built lots of affordable housing projects. And what they all have in common is that they're very cookie cutter and very repetitive, because you gain efficiencies that way. If I have a machine printing the homes, it doesn't care about gaining efficiencies. So you could have 10 different house styles printing 10 completely different things, and the machine will be just as efficient on number 1 as number 10. So we can bring a real beauty, a real elegance, this organic beauty that was not available to us. It has not been available to us in this industry unless you're talking extremely high-end custom. Now we can bring that extremely high-end custom design and style to a very affordable market at a savings on top of that. What a bonus.
How wildfire resistant are these homes?
At the end of the day, it's a concrete home. And so concrete is fire resistant. And so that can give you some peace of mind, the fact. All of our plans, our 3-bedroom, 2-bath, 1,200 square foot house, we dubbed it, named it the Wildfire Restoration House. And so for families that are moving in that maybe have been traumatized as a result of having to flee for their lives out of their homes and have their homes burned down, to have a concrete home, it also meets all the code requirements. There's a whole list that you have to hit, and I'll let Don speak more to that. But it meets the California code for the WUI, the Wildland Urban Interface.
Yeah, there are certain parts of the state of California that are designated as Wildland Urban Interface areas. Certainly where we are planning to rebuild, they are designated as such. When it's designated as a Wildland Urban Interface or WUI area, we have to provide a design that meets a whole list of criteria for those areas. The windows have to be certain types of windows, the attic ventilation can only be certain types, exterior finish, the way you treat the eaves, the type of roofing, and so on. And so one of the decisions that we made internally is that, by code we're required to do that where it is required, but we're just going to make that our norm, that every home that we design will meet the WUI standards wherever it gets built, whether it needs to or not. So if that gives somebody some peace of mind, we would, that's something we're certainly encouraging to do.
And then on the insurance side, I was working for a couple of years reaching out to insurance companies, and to me, it's a concrete home and we meet code. That's going to help to de-risk, and so we finally now have a company that is willing to do it, and so there are other factors that go into it, site specific, but a lot of our wildfire recovery families couldn't get insurance policies on, even if they did rebuild, and the only option they had was the California Fair Plan. And as I understand it, it was just fire and flood were the only 2 perils, and they had to pay a lot more for it. With this, we're hoping that many more insurance companies will identify it, see it as a no-brainer to de-risk, and be able to offer the same perils but at a reduced cost. And so opening up, that families that are looking to rebuild, especially in the recovery areas like Paradise and others. Well, and we do have clients reaching out to us, and that's the deciding factor for them. That's what they're leading with. We want to build in this, high risk area. If they're wanting their dream home and go into a, what could be the next zone, can we get insured? And before we even start in this project, and they want to tick that off, which is really wise for them to do. So with concrete homes, at least that will give them a greater opportunity to do so. We're really honored to be partnered with the City of Reading and our housing nonprofit Access Home. That we know of, and we don't know the whole industry, but that we know of, we're the first 3D printing company that is contracted with a municipality, and so with the City of Reading. And so we're really excited about these initial projects. They're actually the first two that and one that's coming up right here in August, 1st of September. Is in a park, and the first two homes are going to be in parks. And so right here in Enterprise Park in Reading, California, and that's actually the use case for the housing is going to be for a park host home. So family will be able to get subsidized housing for being, a caretaker of the park and closing the gate at night. And so the city was excited about that opportunity. That's benefiting, multiple stakeholders at the same time, and the money, the grant money that has been allocated for those very uses are being put to good use. So we're excited about those, and we really, again, we want to repeat this in as many jurisdictions, municipalities, cities throughout California, partnering with the local government, to do that, the very same thing. Let's get housing out there and help the community to move forward. Yeah.
As we are evolving as a company, as we're getting closer to building and we're doing more designs and more people are contacting us with potential projects, we're finding new uses for the technology. And one example is with this church that we are in the middle of design for right now. Again, as far as we know, that's the first 3D printed church that has ever been done, and it's going to be right up here in Cottonwood, California, of all places. And we started the design work on it, and along the way, our architect reached out to a world-renowned acoustical engineer about designing the shape of the interior walls of the main sanctuary. So this acoustical engineer did so at a greatly reduced price because he wanted to be part of the first 3D printed church in the world, and came up with a shape of our interior walls that has articulations that are 6 inches deep and mimic curtains that are 20 feet tall. And according to that acoustical engineer, at least in the computer model, and the room will seat about 250 people, I believe. According to that engineer, when the pastor is up there giving his sermon, he probably won't even need a microphone, and people will hear him perfectly because the room will be perfectly acoustically tuned right out of the print nozzle. And I've built some churches in the past before, and the sound control, the sound reinforcement is extremely expensive, and churches all have the same thing in common: there's never enough money. So now we can achieve that sound control with literally zero added cost. We just print the sound control right into the building. And so it's been fascinating. And so then my mind goes to other uses for now this newly discovered, like this factor. What if we can apply that into a factory setting that is extremely noisy, and we can control the sound in the factory? Or what if it can be, the uses are endless. We can apply that even in homes, right? Why not make the nursery quieter, print the home in such a way that we can control the baby crying noise. So it's right. The uses are endless. That's an exciting use for it as well.
The other part to us is to see as many of the stakeholders in the community that this would be a benefit. And this brand new technology who else can be benefited? And so we're wanting to help train up the next generation workforce. And so we reached out to CSU Chico, and we're official partner with CSU Chico, and currently working on a curriculum development, because we're at the very forefront of this revolution that's happening with construction robotics, and so it's helping our youth be future-proofed as well, and they're interested. As we present to the 20-somethings, the 30-somethings, and you talk to them about construction, like, I'd rather just work with my laptop. And we said, well, with your laptop, you could print that, and suddenly the hands are going up of, how do I get involved in this tech construction? And so to raising up the next generation, hiring local, training local, and so it's not just housing, but all those other stakeholders as well that we're trying to be real intentional about.